It's a pleasure for me to come back again in Delhi 3 years after the workshop we had in January 2009. We are already invited by Space. So here we go again, 3 years after. So maybe 2014, the next time, who knows when and where. So again, we are going to speak about the tools I have made available on the internet for all the Eclipse community. And we are going to see how they can be used to push the limits, to try to push the boundaries and try to do things that few people do. Because, of course, traveling to view eclipses is one thing, but then you can add another dimension to the whole experience. So the first thing, was in 2005, I needed to find a way, in fact, to prepare all my trips in advance. Of course, doing your scouting is one thing, but before scouting, you need first, in fact, to prepare the trip. And having, detailed maps, knowing in advance where to go is, in fact, the best way to do it. So I will let you, read all those slides because I prefer to spend more time, in fact, on things you can do with the maps. So I will not, re-comment, all the slides. I let you, browse, and everything is explained. One important slide. One of the problems you have when you have eclipses that are low on the horizon is that you need to know the terrain profile in the direction of the eclipse, because you don't want, of course, to have the sun behind the horizon or behind, mountains, for example. Also, when the sun is low, you have to take into account the refraction, because, of course, with the refraction, you might, gain a few tenths of a degrees, which will help. But that, of course, must be computed well in advance. So with the tool, you will be able, the new version of the tool, you will be able, in fact, to compute the local terrain profile in the direction of the eclipse plus the refraction. So on that picture, we have one example in Antarctica in 2003. As you can see, the sun was barely over the horizon, which is, in fact, ice over there. And the location was really important, because if you were, only 5 kilometers closer to the edge of Antarctica, the sun was cut. Okay, so you saw only, part of the sun, and in fact, part of my group that was, there, saw the horizon, cutting the bottom of the sun. I was a bit, further, in fact, inland. You can see, a picture, it was, totality was during the midnight sun. So the sun, was just going down and up again after, totality. And you can see that, of course, if you're not at the right location, well, you will miss everything. So one example of the tool. So I think, most people, in fact, already, use the tool, so I'm not going to explain, exactly how it works. But the fact is, when you click on at any location, you will get the local circumstances. The ones computed over there don't take into account refraction, okay? Because most people, of course, don't need to have this degree of accuracy. But of course, when you are going to an eclipse and the sun is low on the horizon, you must always, check, of course, the profile and the refraction. And that tool will give you, in fact, a view of the local terrain profile in the direction of the eclipse. It will, let you know exactly the elevation and distance of the terrain and compute automatically, in fact, the angle difference between the bottom of the sun and the highest terrain in the direction of the eclipse. So, of course, if it's negative, don't go there. You must have a positive value. Ideally, I would say less than half a degree is risky. Also, of course, because, you never know. You need to have, a perfectly clear sky down to the horizon. Otherwise, of course, you will miss it. Anyway, you can easily study, in fact, any locations that are close around where you are. So on that picture, you clearly see, the sun is nearly touching the horizon, and you have a 0.1 degree difference, which is correct if you look at the picture. Another thing you want to look at most of the time is the lunar limb profile. If you want to have nice beads, finding, for example, the best location with the nicest beads. I don't know if people know exactly what beads are, but on the moon you have valleys, mountains, and so you have light rays going through those valleys, and when totality approaches, you have the last rays going through those valleys, and it does beads all around the moon. Okay, so that tool can help you compute exactly the position of those beads, and also how they will look the day of the eclipse. So we'll see an animation that was done in 2009. It was in China. And float contact is going to come over there. Okay, and so you can see it perfectly matches, in fact, the pictures. We can maybe try to play it again. So you see exactly, how those, beads breaks. Okay, so this is, just an example, and we will see, other example, after. So for me, this is, one important, part of the whole experience. Totality is one thing, but of course you can, get more. Sometimes, duration, of course, is important. Sometimes, having even a short duration might be better. You have to make, choices, and this tool, will enable you to, in fact, know exactly where you're going, what you will see precisely. Of course, if the sky is clear, but this is, what you want to optimize as well. It's the first, criteria that you must check. Then, of course, people like, for example, Daniel Fisher, love to go near the edge of the path. So either, the northern or the southern limits. So, of course, for that, you need to have also, maps that are accurate enough just to make sure that, of course, you are not completely outside of the path. And, even a few 100 meters can make a big difference. So the tool will also, tell you exactly where you should be, and that will help you a lot, just to make sure, you don't miss anything. So I'm not going to spend time. Also, of course, you can also overlay the cloud cover, or even animations of cloud cover, just to try to find, in fact, the best location, because of course, sometimes you have the weather that is locally different from the area around. The current version, of course, does not do the terrain elevation profile. It does do the lunar limb profile, but the new version will be available early next year. I cannot know exactly, when, but most likely before the annual eclipse in May. This is an example of, this time, another application, but only running on a Macintosh, which is also, used to take pictures and automate absolutely everything. So those having, Macintoshes, can also use that application. Otherwise, those having a PC can also run the application using, for example, VirtualBox, and it will emulate, in fact, the Macintosh system, in which you can then run Solar Eclipse Maestro. Okay, let's move. Okay, well, some, cloud cover, but, with an animation that is not running. Over there, for example, using Google Earth to simulate, in fact, a scouting trip. As you can see on the picture above, the green line is the track that I made, using my 4-wheel drive. and at the bottom, it's the real picture. So you can see, I mean, it does match with, terrain elevation. Okay, so now we are going to study a few eclipses using the tool and see what you can do with it. So first example was the 1912 eclipse that went over France, Germany, Portugal. That one was, of course, interesting because it was, for some people, total, for other people, annular. But for myself, I would say purge. In fact, I would say all the studies I made, I considered that even in Portugal, where it was supposedly total, for me it was still purge. Anyway, at that time, of course, they had no way to distinguish between a total and an annular, when in fact the profile of the moon wasn't known well enough. So now let's move to one very interesting eclipse that Glenn Schneider did in 1996, the 0-second eclipse, which, of course, could have been a total at high altitude, which was, in fact, what Glenn was attempting to do. But when you compute precisely the lunar profile and try to see if you still have beads, you do. So for me, again, it's a pearl eclipse, no matter what. Of course, it's so close to total that you can still consider it total, or you can call it total pearl, whatever you want. What is certain is that at sea level, for me, it was clearly annular, a broken annular. So you can see the match between the pictures, taken by Glenn and the simulation of the beads. And it does, match quite well. Also because you have to know that the location, of course, at which the pictures were taken is not precisely known, since the GPS at that time, did not exist yet. So again, you have to find a location that is close to the location, where the plane was. Anyway, I mean, the match is sufficiently good, so you can be confident that, in fact, it was really a pearl eclipse. Another simulation, in fact, with my application, Solar Eclipse Maestro. Okay, now the total in 2003 in Antarctica. So as you can see, ice all around. So again, with the tool, you clearly see, I mean, the sun was 0.1 degree over the horizon, which is exactly, what the tool is showing you. Now in Libya, 2006. So that one, yeah. Okay, in Libya, we made, simulations also, but in fact, we spent, 1 month in the desert scouting the whole area, and in fact, it's mostly flat. So that tool is not really interesting, unless you want, for example, to see it, from the volcano shown over here, which in fact, in the end, we decided not to do. Okay, now one really interesting one. This is what, in fact, I'm looking for. Of course, few people, would love to do it, also because it's pretty hard, but it does, give you an experience that is absolutely fantastic. Of course, the chances of success most of the time, can be very slim, but why not do it? So that eclipse, was an annular that was only visible from Antarctica and over the southern oceans. So most people, of course, had no opportunity to view that one, because the only way was either to be in Antarctica, and it's not only, the Antarctic Peninsula, it's really Antarctica, or be, in fact, on a ship, but in those areas, I mean, there are no ships, going there. I mean, the sea is much too rough. And another thing that was also, very nice, it's an eclipse that is going on over one of the 7 summits. On each continent, you have one highest peak. For example, Asia, Everest. In Antarctica, it was Mount Vinson. So, of course, there's also, a challenge, climbing the 7 summits. And, climbing the 7 summits plus seeing an eclipse from the top of one of the 7 summits is something, really unique. it's not going to, in fact, happen again in my lifetime. So it was the only opportunity. For me, I mean, the eclipse, of course, was important, but it was only one annular, you know, so it would have been a total, of course, it would have been even better. Anyway, I did, you know, attempt, in fact, the whole expedition. That picture was taken, in fact, on the day of the eclipse, a few hours after totality. So you can clearly see that, you know, there were a sea of clouds below the mountain. However, the sky was, you know, clear, in fact. Cold, clear, but anyway. But clouds, you know, did come just after the eclipse, and in fact, I would say 10 hours after, I would not have seen it. So it was a close call. So before, I mean, those mapping tools, you know, Google Maps, Google Earth, the only thing you could rely on was paper maps, which are, you know, most of the time, you know, fine. But the problem is, to go to the mountain, first you have to travel to the mountain. You don't fly over there. And the whole travel, you know, from, in fact, the runway, the ice runway on which I landed, to the mountain, it's over 200 kilometers, which you have to do on your own. So you have to find a way. And of course, scouting is not an option, because you don't do it, you know, a year in advance or 2 years in advance. This doesn't work. It's, you know, once in a lifetime. So you have to find a way to get ready and know exactly where you're going. So you can see, in fact, you know, I flew from Punta Arenas down over the Antarctic Peninsula to Patriot Hills, which is a nice runway in Antarctica, only open during the summer season, in fact, so only about 2.5 months. But you have to know that over there was nobody, because the climbing season was over. So we were completely on our own, and from then, I had 250 kilometers to the mountain to make, before, of course, you know, climbing that mountain. So you see it in Google Earth. This was the path, in fact, that we chose to go to the mountain. So you can see it closer to the mountain. And this is the ascent route that we took. Okay, so now, using Google Earth from the base camp, we will see after that, you know, real pictures, and you will see it does match. So base camp, over 2,000 meters high, and Mount Vinson, the summit is over there. So you cannot, you know, climb straight, not possible. I mean, the cliff over there, you know, is nearly 80%. The slope is 80%, so there is no way you're going to climb this. So you have to go around, climb up along the glacier, and back to the summit. And you see the path that we took to go to the mountain. So all this is a big glacier. So the glacier is at least 300 kilometers long. It's absolutely huge. And that simulation is at eclipse time from the summit of Mount Vinson. So now the real pictures. This is the ice runway. Okay, so you have to land there with a regular plane. I mean, no, you know, skis. I mean, wheels, only wheels. Of course, it's a plane that is made, you know, for such rough landings. An IAU 76. So, I mean, short landings, and you can, you know, adjust everything, you know, the strut, the tire pressure, everything is adjustable. Usually, I mean, the runway is prepared. You know, during the climbing season, people are preparing the runway. But of course, you know, when we landed, there was nobody. So we had to land, in fact, on a runway that was unprepared. I mean, the last time, in fact, a flight, you know, took off was about 2 weeks before. In the meantime, we didn't know what happened. So for the ride, the 250 kilometers ride, we had to use snowmobiles. That was the only mean of transportation that could have been available for us. I tried to look for something else, but nothing else was available. So we had to do 250 kilometers on snowmobile, on a glacier, and knowing that, of course, you can have huge crevasses that, of course, you don't see well in advance. And that, of course, you cannot use tools to prepare for. There you see the terrain elevation profile, which was, in fact, created before we had to do the expedition. Because one thing that, of course, was going to be a problem, if the slope was too high, we would have a problem, pulling the sledge. So this, must be taken into account also. This is the dream vehicle that I would have loved to use. Unfortunately, not available at that time. So I did try it. It's great. I mean, it goes much faster because, the snowmobile, we are going at a maximum of 30 kilometers per hour. With that, in fact, a vehicle, you can go easily at 100. It just, flies over the ice. So arriving, in fact, to the base camp. The base camp is over there. So we are still, on the glacier that is behind. So you have to climb all that way and then go up. So as you can see, the picture matches the simulation in Google Earth. This is a view from the base camp, and you see also, some low clouds, which we had pretty much every day. They were, coming, going. Over there, the terrain elevation profile. So we had to, in fact, build 2 camps along the way. So one low camp, one high camp. You can see one of our tents. We were only 2 people. And as you can see, there is a wall of ice around the tent to protect from the wind. Over there, you can have winds up to 200 kilometers per hour. So you don't want to get caught. So in fact, the first thing you do when you stop, you build a wall to make sure that the tent, is not going to be blown away, and of course, with you inside. As you can see, the weather was also, sometimes quite difficult and stormy. In fact, we were pretty lucky to see that one. Another one climbing along the glacier. Again, a bit higher, another one. So we, in fact, took that route, goes behind. This is nearly on top of Mount Vinson. Over there you have Mount Sheen, which is the 3rd highest summit in Antarctica, and Epperle, which is, I think, the 5th highest summit. And the route we took is, goes down and down that way. In fact, that part is one of the most difficult because it's an ice fall about 600 meters high. And the seracs are, I would say, 10 times bigger than what people usually see even in the Himalayas. So you don't want to make any mistakes. Another picture from the summit, and one from the Eclipse. So as you can see, it's pretty cold over there, minus 40 Celsius. And it's summertime. Then, of course, you have to add the wind chill factor, and we had some wind. So, minus 65, maybe even lower. And, of course, you have to take pictures in those conditions. At the time, I did use CR film cameras because digital camera, would not last even 10 minutes in the cold. But one problem you can face also with film cameras, when the temperature is that low, the film is breaking. So you must, have a manual, fully manual camera, and otherwise you can, have trouble. If you have a battery, of course you must charge it. So you must be careful about absolutely everything. The same, for the lens. It was, a basic, catadioptic lens. So, just like a telescope, no fancy equipment. It was the only possible way. Also, of course, because to carry it, to carry everything, you know, on your back. There is no one, you know, helping you. So the less you take, the best it is. Okay, now one good example, the total that occurred last year. You had the choice between a flight, which Glenn, of course, you know, wanted to make because of the duration, and also he was certain to see that one. You could also go in French Polynesia or Easter Island. Both trips were, for most people, pretty expensive. So then you had one last option that was, in fact, I would say, really interesting. Low budget, but of course the weather, you know, was uncertain. And also the sun was very low on the horizon. So you had to make sure that you were at the right location because you have the Andes that were, in fact, in your line of sight. So you have to shoot a location that, in fact, is high enough to be certain to have the sun over the Andes. So at the time, you know, my tool, of course, you know, was only, you know, being tested. So I wasn't sure that, in fact, all the computations were correct. But that Eclipse, you know, in fact, allowed me to check all the computations and make sure that everything was perfect. And so we tried to, you know, look for different locations before going there. And we could see that you had, in fact, to be close, in fact, as close as possible, in fact, to sunset and on high grounds. If you moved any closer, in fact, to the mountain range, you would not see it, no matter how high those mountains over here can be. So you see an example. Okay, there is a town, El Calafate, that was, in fact, below the mountains. From El Calafate, you can see the sun. It's just cut by the horizon, by the mountain range, which is also, you know, what the tool is saying. So, of course, you know, people didn't want to stay in town. They had to, you know, move out. And here is an example of people that, of course, didn't use the tool and didn't check in advance their location. As you can see, the sun is going behind the mountains. This is exactly what you don't want to.
Oh my God, it's just going down. Wow.
So, of course, you know, they have the nice shadow cone. But they barely see the corona.
Look at the shadow.
Yeah, well, the noise, yeah, the sound is.
Well, for crying out loud.
But the end is interesting also. So you see it's completely hidden. The fact is, you know, it could have happened also in Antarctica in 2003. Yes, you see the mountain, the horizon is Lytton. This is where they should have been, in fact, higher ground. So, you know, big mistake for them. So, of course, you know, it was an inexpensive trip, but they missed it. They had, you know, clear sky, perfectly clear sky, but because of the mountains, they didn't see anything. So now, next year, in Australia. The biggest town, in fact, in the path is Cairns. So it's easy to get to. I mean, you have an airport, even international airport, which is quite nice. But of course, you know, staying in Cairns is not that interesting because you have a cape in front of the town that, in fact, will obscure the horizon. So you can see totality because it's going to be over, in fact, the cape. But you will miss sunrise. You will miss, you know, the partial phases up until, I think, half an hour before, you know, totality. Anyway, it's a choice that you have to make. But, you know, that tool, you know, allows you to exactly determine what you will miss exactly. So let's take now another example. You move a bit to the northern beaches, not that far away from Cairns, but at least the horizon is not obscure. And you see what the tool says. I mean, it's perfectly flat. Now, if you move inland, there is a mountain range, in fact, along the coast that is about 1,000 meters high, 1,000 meters to 1,500 meters high. So the same, you have the mountain range and then the sea that is, of course, you know, flat. Now let's see Lake Turkana, 2013. Many people, of course, will go and try to look for duration, but they might get duration and clouded out. So anyway, personally, I prefer to choose short duration, better weather, and also nicer surrounding. So it's a personal choice, and also nicer beads. So of course, it's going to be less than 20 seconds. But hey, it's 20 seconds that are great. Here is a simulation of the beads that you will have. I could show, you know, one simulation. In fact, you know, in Western Africa, you won't see that many beads. One eclipse I'm looking also forward to, 2014 in Antarctica again. I guess nobody else will attempt that one. It's in the most remote and coldest place on Earth. Anyway, and you have to winter over, so probably spend 9 months in Antarctica. So crazy, yes, but I would say it's once in a lifetime. So anyway, I mean, you can, you know, use the tool to make the simulations. Another one for India, I mean, that can be quite interesting. 2020, you have an annular that is very close to a total. I mean, it's 0.99 for the magnitude. But of course, if you climb a high mountain, you slightly also increase the magnitude. You can get 0.999. Okay? So I'm studying the whole climb. I mean, that one is quite hard. I mean, I don't think, you know, I can succeed. But anyway, it's only one annular. Probably I will try. So if anyone in India is interested, we can talk about it. It's going to be, I would say, a very interesting one. It's a difficult climb anyway, so, you know, get ready, you know, try to train, and you should be able at least to try to make it. So you can, you know, watch the rest on your own. That's it.